Again, hi everyone. Welcome. I'm Agustina Jaime. I'm from McNeil, Europe. In this webinar, we have the pleasure of having Ekkehard Altenburger with us. He will show his versatile approach to using Grasshopper as an artist. The webinar will center on the utilization of various plugins like Weaverbird and Kangaroo2 alongside the whole robotic framework, demonstrating their applicability in both smaller and larger robotic systems, including ABB, UFactory, and universal robots. So Ekkehard Altenburger is a German artist based in Hong Kong. So it's pretty late there right now for him, I think. He has a background as a master mason, and he later studied in Bremen, Edinburgh, and London. Architecture has a significant impact on Altenburger's artistic endeavors. His project can be found in various public and private collections, as well as in the public domain. His current research focuses on using parametric algorithms in idea development and the creative process, including incorporating them into traditional Vietnamese lacquer painting techniques. He serves as an assistant professor for sculpture at the Academy of Visual Arts in Hong Kong, where he established a robotic laboratory for digital fabrication. Altenburger's pieces have been featured in exhibitions such as Amber in Vietnam, Hanoi, and True and False at Berg Ramfeld in Bavaria, Germany. So as explained before, we have an open chat that everyone is welcome to make questions and use during the webinar. And I will read them at the end for Ekkehard to answer them. So we will have 15 minutes Q&A at the end of it. So welcome, Ekkehard, and thank you so much for being here today. And whenever you're ready, you can start.
Well, I will start right now. Thank you so much for joining us here for this webinar. Yes, I do broadcast from my studio in Hong Kong. It is now 10:10 here, local time in the evening. And I am excited about showing you what I have used, particularly Grasshopper, for in the last few years, and the way in which I approach the technology from a sort of a recent perspective, but also how it is tying in with where I'm coming from as a sort of a craftsman. And perhaps we have also time to look into where the situation is, how to feed it into teaching. I teach sculpture. And I will also show you how I use it, Grasshopper definitions, in our we are still installing a robotics lab, so we're fine-tuning everything, but I can show you for the first examples what we're going to do there. Okay, Augustina, you can they can all see my screen that I am looking on to my left. I'm working on two screens, so you can see two pictures. On the right-hand side, me with a robot. On the left-hand side, you see an artwork where sort of hands are. You can all see that, yes?
Exactly, yeah, I can see the presentation.
Wonderful. Okay, so now you will see me. I focus now from here to the second screen. As you all know, when you work with Grasshopper, you need two screens and sometimes three. It's very useful, so you'll be well fleet-footed working on two screens. Everybody is really since the pandemic. Okay, I want to start with this slide, and it gives you a sort of a snapshot of where my work right now is. On the right-hand side, I'm mounting a milling tool to our IRB robot. We have a 25 kilo, it's the biggest one we have at our school, at our university. On the left-hand side is one of my larger pieces that was finished, I think, in May for the opening in June in Hanoi. My life splits a little bit between Hanoi and Hong Kong. My wife lives in Hanoi, and I have started working there in the lacquer studio. I interested in the transition of traditional techniques and how they merge and live in the contemporary world. So here a picture to illustrate that further. On the left-hand side, I was a master mason, worked as a stonemason on a Gothic cathedral in South Germany up until the late 80s. And here is one of the pieces I carved. It's the capping of a small staircase. So it built a little dome. And I also had during that time learned how to make these technical drawings, make templates to carve these pieces. On the right-hand side, so moving very quickly on, about 25 years later, a work called Twisted Column, which is in Gateshead. And I made this in 2005. And anybody who has worked in Grasshopper kind of recognizes shapes like this. So this work is kind of an early parametric work when Grasshopper was not, or was probably in the planning stage as far as I researched it. And I think early versions were in 2008 when it was launched. So the sculptural work I have done and produced, you can look at my website, a lot of it sort of reflects parametric aspects. So things that we are kind of quite used to it right now, but this work is almost 20 years old. So making plans and executing it is something you constantly have to do in sculpture or in architecture, less so in painting. So, for example, on the right-hand side, this is a marble piece which I carved, and I constructed those webbed grid by hand. So I made technical drawings. I learned it all, you know, back then when I was working at the cathedral, and then later on, as Augustina alluded to, I studied in Germany, in Edinburgh, did a master's in London, and I was working as a sculptor, as a visual artist in London for 17 years. So I had my own business in London before I moved to Hong Kong. So the first time, so the reason why I worked and moved more and more into cut-based system was that my work demanded it. The work got bigger, the commissions got bigger. So the largest piece, when I really had to seriously go into learning, I worked with Vectorworks at the time, was when I worked on a large fountain piece in central London that was 40 by 60 meters. The first time I moved into robotics was in 2013 when I made this piece. This is for the university in Nottingham, for the science park. On the left-hand side, you see a milling robot in Carrara that pre-milled a 14-ton block. And on the right-hand side, you see the finished piece. What I did, I hand-carved, I designed these knots on the spot in the studio in Italy, and I only used the robot to do the rough milling. So I used it like I think in Italian they call it spacciatore, so people who block the rough work out for you. So I need to keep a bit of an eye on the time. So this work kind of represents a way I like to work. I use technology up to a point where I am better than the technology, or I'm interested in the aspect that technology cannot do for me. So that craft aspect, that handmade aspect is very important to me. But a lot of the stuff is just neck-breaking work that machines can do much better, and in the end, also much cheaper. So since then, and I remember that the technician I worked with. So I learned to operate the robot very basic, could switch it on and off and change the speed setting, but that was pretty much it. But I looked at early versions of Grasshopper then, so I remember that. At the time, I was also still working with Vectorworks. Apart from my sculpture work, I make a lot of wall-based work. So on the left is a work called Black Hand, I think from 2016. On the right, a work I did during the social unrest here in Hong Kong. The university was shut down, but I could go in and I made that work in 2019, I think. So they are quite big, and these are, I call them sculptures on the wall. So they are on aluminum panels, and they are on 3 layers, and I hand paint them. So they're sort of color field explorations. So working with the wall and color, when you go back and think about the work I did, the twisted column pieces, I've always painted my sculptural work, very often mainly stone pieces. So color is always an aspect to it. And the reason why I started working with Rhino, I had various occasions where I had to look at Rhino as a program, and I always found it difficult. Because none of my friends work with it. So usually it's quite good if you have somebody to kind of show you around, the 4 working windows and all the tools around. It can be a little bit frightening. The reason why I actually started it, I used up until 2017, 2016, I used Vectorworks, and they switched to a subscription mode, and they Rhino launched Rhinoceros on Mac. And I was always working on Macs. And it was very cheap. So I thought, I pay that subscription, it's not a lot of money. And so I just sat down and somehow learned it. And the more obviously, and I probably speak to, everybody here is probably fleet-footed with Rhino and to a degree with Grasshopper. You just kind of grow and learn the capacity and the capabilities of programs the moment you actually engage with it and you get something out of it. Because I always use touch technology as a tool to make sculptures, because I was always, the carrot is always at the end. I need that TXF file I can send to a factory to cut something in steel or mill something or so on and so forth. I had the idea of a robotics lab very early on when I got the job here in Hong Kong, and I had a very, very good boss at the time, and I said, Professor Louis Nixon, he's now head of research in Norwich University, at the art university there. And I said, Professor Nixon, we need a robotics lab because I think it's important that artists have access to robots, because artists have always worked with technology and we need that. And we somehow managed to buy a robot. Everything got stuck during COVID and we had to install it. It was a long story short. It was very difficult to install our robot because we were in shutdown. We bought the ABB robot in mainland China, which sits just 30 kilometers away, but China was, as you all know, completely shut. We could not get the engineers over, so installation was complicated, and we're still dealing with the repercussions of that, but we're getting there. I was taking a sabbatical in 2021, the first half year. I wanted actually to be in Hanoi with my wife, but we both got stuck in London. And I thought, okay, this looks bad. I will be stuck here for a while. I better sit down and learn Grasshopper, because if I want to run the robots, I need to learn it. So I did a very basic introduction course with Grasshopper Rhino Europe. They offered, I think, a 1-week course. I did 3 days, a sort of like an early stage course. And I have to say, I was completely overwhelmed. I was actually really frustrated by it because the teacher was a Taiwanese, very good Taiwanese guy, but I think he had the impression he needs to, what is the saying, value for money. And he tried to cram in as much as possible into that course. And it was absolutely overwhelming. But because we had lockdown, I knew I need to learn this. I just sat down in the months to come and just went for it. We were stuck in a house. My wife was downstairs running the office in Hanoi. She was managing, and I was on a sabbatical, and I was in a room upstairs, and I just learned Grasshopper. And luckily, there's so many YouTube tutorials, and I'm pretty much speaking probably to most of you who all learned most of it via all these fantastic people who have put things on websites, on Reddit, or on Food for Rhino. And when you start going through definitions, or you just replicate what you see on screen, obviously you figure out gradually how it works. And I do the same now with my students. Like this morning, I had a fabrication class. I do a basic technical course where we teach 3D fundamentals, so 3D fabrication techniques. And as I teach as part of that Rhino and Grasshopper, and always in hindsight or with the aim to produce something with a laser cutter, with a 3D printer, or we also have courses we have a CNC plasma cutter where we can cut into steel and the students can weld stuff together. So that carrot at the end for me is very important. So I probably, some of you here are absolutely far more experts than I am, but there are probably some artists amongst you who have just kind of dipped their toe into learning Grasshopper and probably are equally frustrated as I was when I started. So I want to show you I went back, it was an interesting experience preparing for this talk because I needed to go back and look at what did I actually work on in those early days. And I want to show you what I sort of, I want to show you some early examples of Grasshopper code I was working on and tried to figure out. So if you look at this definition, I hope you can all see now the Grasshopper Rhino file here, application. So you remember I'm also doing a lot of wall-based pieces and designing them. Initially, I did it in Vectorworks, later on in Rhinoceros. At some point, I did work in a little research lab in Finland. I learned a little bit of SolidWorks, but that was also a real pain in the neck. So I thought revisiting something you have already done in another program, but try to replicate it in Grasshopper is a good start. So for all those who want to learn Grasshopper amongst you, look at something you have done in the past, perhaps with the help of a Rhinoceros or another CAD program or Blender, and try to remake it in Grasshopper. That's a technique I also do with my students. They first need to design something in Rhinoceros, and then they need to later on replicate the same thing parametrically. I think that's a good little exercise to do. So I didn't really do it sort of consciously, but in hindsight, looking at the files I had, is interesting to kind of see. I obviously subconsciously chose that method. So when you look at this, this is a parametric way to create triangles, and you remember that sort of color piece. It sits here actually on the wall, and I've done a whole range of them, sort of colored pieces that are based on an old Amiga color scheme, so triangulated pieces. And so I just thought, obviously, I try to do this and to figure out, and obviously when you can bake something like this is very useful because then you can send, I don't know, the final object to a laser cutter. For me, I have to send it across the data just to me in China, and a few days later it arrives, and then I can continue to work with it. So let's increase this a little bit, that we have a little bit more space. So here, you know, you all know these. They are all simple parameters from the original parameter sets. There's nothing fancy about it. What I was actually quite impressed with that I already used things like list items. So using lists is something I'm still struggling with. To be honest, it's something I'm really struggling with, but I always invest in the time because it's a very useful thing to be able to do. And series obviously is a very useful battery and additions and subdivisions, and then deciding which part of an area you need, very useful, and then whatever, ending up, for example, here with something that I could bake and then perhaps continue to work with in Rhino. And obviously with this being parametric, and so this is the initial scale. Obviously I could change this, but I was interested in triangulations, and this is the so obviously just a simple scaling of subdivision and subdividing it, but running through this is for me a very useful thing, because designing this in Rhino, once you've done it once and then changing it is awkward. It doesn't really give you that many options. So these are sort of one of the definitions I sort of started with. Yeah. So nothing super fancy about it, but kind of working with these sort of basic structures is a very, very useful and powerful skill you should try to acquire. Yeah. So going back to my presentation, I have always been interested, obviously, as an artist. I also live with the history of artists, and you look at things. And this is a painting by Eugène Delacroix. So we're talking 1830s, and you might know him. It's a famous painting. Is in Paris, and Eugène Delacroix was particularly famous for his use of color. And he was also an artist who did write about what color does, particularly when you put, so he was the first one to kind of notice and play with complementary contrast, something I also do in my work. So when you look at this door has a little green. When you see the original, it's a very dark green next to red. So green, red, very often gold next to blue. Yeah. So areas like this is a sort of a classic complementary contrast, something he did join the one of the top guys in the administration to the Maghreb countries, not that they were called Maghreb, but he went to Algiers, and so he painted these harem scenes and was obviously very popular at the time. But he was writing about the color and how colors, when you paint them next to each other, how they intensify, and obviously that's what complementary contrast does. You know, it highlights color and gives different depth to colors. I was always interested not on the one side, the color aspect, but I was always interested in this little part. It's this little floor, these floor tiles. So I thought, I'd try to kind of replicate that in Grasshopper. So let's have a look. I think I have that here, Woman of Algiers. Okay. So, and this is, at the time, this was something, and I did not change anything. So this is the first time I opened this a few days ago. So this is done early spring 2021. So, and you can see the sort of chaotic, I would not allow this to happen anymore. I would be a little bit more organized in the way I organize my Grasshopper code. But, so on the top, and what you recognize here is a very similar structure to the structure I used in the triangulation. So, and that's another very, obviously, most of you know, a very powerful thing. You just copy and paste parts that are useful and you bring them into another definition. At the time, I was struggling. So basically what I wanted to do, I had a little plotter and I wanted to plot them out. So with a pen plotter, yeah. And obviously I wanted to get more contrast. So I needed to figure out how to subdivide these little triangles here. And I remember I was working on this for days. I could not quite figure out, but I ended up using triangulations. So using the math tab, and I used where the triangulation? Trigonometry. Here. I found these ones. So I thought I still remembered how sort of, you know, the Pythagoras and sinus, cosinus, tangents. I only know the German words. So sinus, cosinus, tangents. So I used these ones, and the beauty of that. So if I ever have to explain my son how triangulations work. I think this is a really beautiful illustration how trigonometry works. And then you have everything, you plug something in here and you get all this out. So wonderful. So once I figured out I can do it like that, so hold on, this is the length. And then I could subdivide it. The subdivision is, I need to revisit this. The subdivision is here, I think. Is it? Hold on, where's the subdivision? And this is where the computer starts to struggle. Hold on, where is the subdivision? I'm looking at a rather old code. So that's the scaling. I just did this the other day. Where's the scaling? So here. Did I use a divided the series? Now my computer is struggling because it's so many. I have so many programs open. This is something that I usually have not much problem with, but obviously with Zoom going and other programs open. Here we go. So yeah, it was that slider. So I obviously have to be very careful with working Grasshopper code with so many applications open. But obviously here is the subdivision of the triangulation here, and you can see you can change these triangulations. So a rather complicated code, but kind of I was quite proud about myself how I sort of just thinking about a problem and figuring it out. And I'm pretty sure this is a terrible way of doing this. And there are far smarter ways of doing that, particularly for those who are good at mathematics. But for me, it worked and I figured it out. And there's also, I think, there's an element of satisfaction when you actually figure out the Grasshopper code and you get something out at the end that you want and that is useful for you. I always find it very satisfying and exciting. And I can see that also replicated in when I sort of work with my students. So, okay, so these are very early examples. Oh dear, I need to speed up. Okay, and here examples of plotting, and then obviously I used this definition and also projected it onto an uneven surface, which is great. You know, obviously Grasshopper is great for that. I would just wonder whether this is now more sophisticated. I think I'm going to let this Grasshopper code out because although it's kind of Kangaroo, I have used the Kangaroo solver quite a lot. Let's try it out. I'm not quite sure. It might crash the system, but let's try it out. But this is also an example and the plotted version of it. So which I did during. Perhaps I need to close a few things. And I open. Oh dear, where is this now? Right, webinar. Grasshopper code here, Super Collider. Here we go. So this is a definition I actually found. Hold on. On the web. I think you might have seen it. I think it's something they did in the Zaha Hadid studio. So, and somebody posted a definition how to run this Grasshopper, this Kangaroo solver. So that's under Kangaroo2. I'm pretty sure a lot of you know this solver, this plugin. So it's a great engine for tensile structures. And so I need to stop this now. Okay. And here actually I saw, I think on the Guardian there was there was an article. That's the stuff you do in lockdown. There was an article about women doing butt lifts, and there was this picture of this woman, or just that butt lift picture. I thought that looks rather nice, and I was discussing this with my wife, and so I thought I'm just going to use that for this. So what happens here is that I use the shape, a line, a double line, and animate this with various kangaroo solvers, and then double lines, triple lines, and then I exported those lines and printed these lines in different colors. So, and I'm glad this didn't, hold on. So here, as you can see, so, and then I exported these different lines, I think because I used it with two different plotter pins, plotter markers, and made these drawings. So again, this is all during lockdown. I need to keep an eye on the time. Another one, another sort of color field work of mine. I have worked with these color fields, obviously always interested in color and how color works in space. It's an interesting sculptural aspect of it. Let's quickly have a look at this because it's a good random here. And I think here, so these are sort of things I found on the internet, and then sort of kind of made this sort of, I had a really complicated solution to start with, and then it got simpler and simpler and simpler with people making suggestions, I think in Food for Rhino, and I nicked this timer, for example, is a very, you find all these little snippets. Food for Rhino, obviously a fantastic resource. This timer, I use it for all sorts. And again, going back to replicating what you have done already. So just an animation of 256 colors. So I just thought, and later on I did an animation and I showed it in an exhibition. So based on this, so and then I used there's another, the Horser plugin here. That's a camera, which is very useful. So I guess you do that as well, that you have folders where you have certain things like timer elements or color making elements as separate Grasshopper definitions. And sometimes you just need to kind of build these together to kind of make some work. So having a good archive is also highly recommended. So so I think it's important to kind of see, what, you need to have the right intention, because you need that carrot at the end to sometimes go through different difficult stages in Grasshopper development to find the solution. So my wife moved to Hanoi, and my life is sort of split between being in Hanoi and being an academic in Hong Kong. So I was always interested in lacquer technique. Lacquer technique is a technique, an old technique that is originated in the north of Vietnam, and it uses a tree resin that is diluted with really strong solvents and applied. It originates from preserving wood. And anybody who has ever been in Vietnam or Laos or Cambodia knows that in heat and humidity, same here in Hong Kong, things just rot away. So in the 12th century, they developed this lacquer technique to preserve wood. And then subsequently, at some point, artists used it as well. The technique involves a lot of processes. So the end, for example, here, this work here, Agnes Martin's Lungs version 2, probably has about between 35 and 40 layers of all sorts of things. So lacquer and gilding. So what Vietnamese lacquer does, every color is supported behind with either a layer of silver leaf or gold powder or silver powder. Now, why is that? The pigment, the resin, is a sort of quite a dark brownish resin they gain from trees, and it's diluted with petroleum, and we mix pigments in. So the pigments are usually semi-precious stones. So they are powdered pigments. So they're not liquid pigments. They're powdered pigments. So what happens on a sort of atomic level, you have the pigment and the resin forming this bond, and the resin being translucent, and there are spaces in between the pigment. Behind sits a layer of silver, for example. So if you have light going onto the surface of this painting, it pierces through the pigment, not through the pigment, but through the resin, because it's semi-translucent, and you have a reflection effect on the layer of the silver or gold. And this depends on what color you're using. So I am learning this technique now for already 1.5 years. And it's a little bit like gardening. You need to start, you work on these pieces for a long time. I mean, this piece I started in I think in September, October last year, and I finished it in April. Because you need to build up layers and layers and layers, and then you polish things down. Now, these are Weaverbird, so plugins, a plugin that sits within Grasshopper, that are kind of quite sculptural in their character, and I always liked them. Once I discovered Weaverbird definitions, I thought, oh, that's the sort of stuff I'm kind of like the sculptures I'm making. They're very close to the sculptures I have made in the past and still currently make. So here, this gives you a sort of a rough idea how this works. What I do, I design the work, and you can see they're kind of three-dimensional, and then I take snapshots from the back and the front, and yeah, I do that also parametrically, that I can export views from the back and the front, project them on the ground plane. Rhino itself has a great tool for that. Obviously, you all know Make2D, one of my favorite commands in Rhino, because it's very useful, particularly if you want to use laser and plasma cutting based from a 3D object. So I do the same here. So I take snapshots, and then the transition is basically I get it printed out, and we transfer it very old school with a traditional pin and trace onto these boards. These boards are already painted for about, so a lacquer board is painted so many times before you even get started. So you start with 12 layers of clay. There's wet clay comes onto a wooden board. Wet clay, then 5 layers of lacquer, and then silver layers, and then pigment layers. So this blue here is already painted about 20 times. There's also bits and pieces, layers, 2 or 3 layers of silver underneath. So this is just to get light back to reflect, for the light to reflect. So they're really luminescent when you see them. And here you see the traced and the lacquer. And this is the base layer where silver, and then this is, so they are all different. So this is gilded twice. this is the silver gild, and then this is gold gilded, and then you paint on top of it on various layers, and in between you sand it down. So these are one of the works, and I had an exhibition in Hanoi in June with 12 of the first pieces together. I was shown with 2 traditional lacquer artists in Hanoi. So these are other, these are kangaroo definitions, tensile structures. Some of you might recognize them. And I sort of translate them into these lacquer paintings. Sometimes you also end up with a golden surface at the end. So yeah, so these are sort of lacquer pieces. And yeah, they're all based on Grasshopper definitions. Here are some shots from the exhibition. This is also the piece you have seen in production in the first slide. This is Van and this is Gan. They are both very established lacquer painters with their partners. That's me with my wife. And now we come to robotics. Hold on, I actually wanted to show you one Weaverbird definition at least. Augustina, you need to give me a warning. Martin's lungs here, this one. Let's have a look at this. So if you look at my website, or I have made a lot of these types of sculptures, not with this pattern, but these sort of shapes. What I like about working with Grasshopper is you have to. I approach it with an inkling. I want to do something a bit like this, and then I see how the code reacts to what I do, and I find it quite intuitive. It's not. When you work as a sculptor and you're modeling something, or I think clay is probably the closest in terms of a physical material to get to this. Otherwise, when you work with these Grasshopper definitions, you can take a volume like this, and give it a height, and then you throw a few attractor points in it. So you populate the geometry with attractor points, and you give it some, charge. And you cocoon it, and you mesh it. And for this, I do like these Weaverbird definitions here. Catwell Clark, some of you might know this. It's a very, very useful one. And then you end up with this mesh. And I have made sculptures from these as well. So, and these definitions, they're very, very useful. I have made various sculptural pieces. I'm just going to plug in a few things, how they look like, I'm not quite sure. So these are all Weaverbird definitions. Yeah, this one is this one here. So, so Kangaroo and Weaverbird. Weaverbird I have explored to a great detail, but Kangaroo obviously is a very powerful tool with many, many options. And at the moment I'm working a lot. At the moment I'm working in Vietnam with these sort of balloon structures that collide into each other, and I paint them. So that's what I'm currently working on. But I want to spend a bit of time looking into robotics, because some of you might be interested. So this is just the open day we had last weekend. And so let's have a look at some. So I need to close these one. And let's have a look at some hull definitions. And for this, I need to open. Hold on. So we look at a simple tool calibration. And here I have to load a rather large file. Here we go. So, robotics. Let's quickly activate this. So, for anybody who's interested in robotics, we are working with HAL Robotics. So HAL is a plugin tool that is written for Grasshopper, and quite a few universities use it. We have formed quite a close relationship with them, and for institutions, it's actually really cheap. I think it's about 300 euros per year, per seat, per machine, and you can also log out, so more people can actually use it. So you can work on these codes without being logged in. So it's a very, very useful tool. I quickly talk you through it. The great thing about HAL, because we have 3 different robots. So here, apart from being able to check your code and getting warning signals if you do any wrong movements, because we have feeds into the head. So we have data cables and electricity cables, as well as pneumatic cables that go all the way to the top of our robot. So it's not rendered here, but hold on, let's move this a little bit on the side. Have a bit of a better view of this one. So this bigger robot has cables all the way up here. So obviously you have to be careful not ripping your cables off. And HAL is great for that. It will give you warning signals. Quickly talk you through it. So the first thing is ABB has a great archive at what types of robots they serve, and they have complete coding for. So we have an ABB, and we have UFactory and Universal Robot. UFactory is a cheap Chinese maker, and we have just commissioned HAL to write this plugin. So this plugin, if you ever buy a UFactory robot, and you get them for about $5,000 US, and you use HAL, we paid for it, and we paid with good money. But so they're also now part of this archive. And alone for the ABB, there are, I don't know, hundreds of robots. I don't know how many. The archive is ginormous. So, and so I'm not going to change anything. So this is the robot we have, so which is in the archive, and then you have the machine, and you can check. And also, you then parameterize all your entire environment. That's something we set up at the moment. So the way we set up our code is we have the robot, we have the end effector, so that's the tool that goes at the end. So that's the tool and where you attach it to. And that goes into the home position. So this is quite an important part to position the home position, and that also has an effect whether you rip your cables off or not, or whether the robot does any funny movements, but the robot will give you a warning signal and you will not be able to send the code. So this is the speed settings and the TCP settings. So obviously you have to tell the robot in which direction you need to go, yeah, with the tool. And here you can, this is a rotating table. And this is sort of simple movements. For example, I have set up a simple calibration movement. We have made a little needle where we can place a point, and the TCP also has a point here. And this code is to test in real life whether these two physical, so the real tool on the real robot and the real tip on our tool rack actually correspond. And then obviously you need to run the program and adjust the program here, or the settings here. And this is basically a point-to-point movement, which is called frame. But you can also have linear movements and so on and so forth. So this is the procedure. With speed settings, you can also have built-in waiting times. And this all feeds into signal. That's the cabinet, the control unit, and they are quite big. And again, this is a hull, making a little bit of advertisement for hull. You have controllers, and there's a whole archive of controllers. So this is so these are current ABB controllers, and they're also updating the archive all the time. Not going to make any changes. And we set it up. You can also, this sits here, this is the same as here, is to check whether the code is correct, and you can actually also check on warning signals here and fix them if needed. And we set it up that we send this one once you have the IP set, and I connect my laptop with the controller, and then I send this code directly to the control unit and send it to the pendant and execute it at the robot. Now let's have a look at another. Agustina, are we is there time for one more, or are we running out? Because I want to go to questions as well.
You can keep going if you want.
Okay, I have just one more code which I would like to share. Up to now, probably the most complicated code we have worked on. This is also an experiment we did on our opening day. And here, this is one of the cheap Chinese UFactory robots. And here, we did an experiment with a colleague of mine, Peter Nelson, who was also working with me in the robotics lab, great guy. And he comes from Chinese ink paintings, and he's interested in things like painting with robots. And so this is a simple experiment to take a brush, put it in a container, and just make little brush strokes. And then also the code is this. So things can become very, very complicated very, very quickly. So you need to become fleet-footed. And so let's have a look. Oh, I have done the setting really quickly. Let's slow this down a little bit. Question is, where is it? Where's the setting? Speed setting. Here. Let's do this a little bit slower. Still too quick. Here we go. So, oh, and this one as well. This is the move to the home position, and this is the execution. So, and this is basically inking, going back to the ink pot, and then I did speed this up in order to kind of show you the whole sequence, and then it goes back to the home position. So, and then, yeah. And also what Hull has these wires, which I don't like. They are basically, they are, because things get so complicated, but they're basically remote wires. But sometimes you lose track where they actually go. So this goes to the combined, and then basically this is also, then we send this to these little cobots as Python code. So the code is Python code, which we convert, and then we can send. So we can, the great thing about Hull is that we can use at the moment 3, soon 4 different types of robot with the same software, and we can also exchange code, perhaps just scale it up. And what we do here So this is, to give you one example of really complicated inking. So this is the inking. This is where we ink. This is the artwork. We can move the artwork in on the table. Then we have also then little cone head, for example, which is, yeah, you need a big screen for for where's the tool head here. Yeah, for example, this is just, you know, we didn't model a brush, but we just kind of, you know, you make a little cone and you stick this cone at the end of the tool head that goes into your tool as an attachment, and that goes into your control box, and from there you can export it as a code to your robot, and you can, you know, you can work on the code until everything is fine. If you do something stupid, the robot will, or the animation will turn red, and you can then check here whether you have done anything wrong and rectify it. Hold on, it's frozen now. Okay. And I think, yeah, I have other, you know, at the moment I have, we are now at the moment where we will start teaching this in the next semester. So we are doing tests and experiments at the moment, setting up the virtual lab, and I'm getting to grips with the code. And that was really the reason why I initially wanted to learn Grasshopper. But as a byproduct, I end up using Grasshopper now in lacquer painting. I already made one very big sculpture with a Weaverbird definition. It's in America now, which was produced during the lockdown in mainland China. So you do all these sort of things. So once I realized the capacity of this tool, it just opens up this world. And it also, the great thing is, a lot of institutions use Grasshopper now, and as for these sort of parametric tool systems, or these sort of, you know, you have batteries where you plug in some. So my colleague, who's Peter Nelson, who's teaching Blender is adapting this now, and as far as I know, AutoCAD does it. We also teach Touch Designer. They use similar sort of parametric tooling now. So our students are getting more and more used to doing something with batteries and plugging certain nodes together. So it's something that is very, very useful. And I think we also have to kind of change the mindset in our students, in our own work, that this is probably the way forward. This is how systems will evolve, and where we can also kind of connect to other systems somehow. So I think I have talked now for a whole hour. Before I lose my voice, I would like to obviously get some questions answered. There are 77 in the chat, I think. So Augustina, back to you.
Well, first, thank you for that demonstration. That was really, really interesting. So I have a question from Victor Soto. Please, can you tell us where can we get the different robots?
Where? Well, UFactory is a Chinese company, but they, for example, have offices, I know, in London. I'm sure they have somewhere. The UFactory are the cheap ones. So this one here. Then ABB is the biggest robotic manufacturer in the world. Go to their website. I don't know. They must have. It kind of depends what type of robot you want and what you want to use it for. Yeah. There's KUKA. I know, for example, KUKA has already a plugin that is ready for Grasshopper. You don't even have to pay for it. So KUKA robots have already a KUKA PRC for Grasshopper. So you don't need HAL. HAL is a very useful tool. So for, yeah, then there is, we have UFactory. We've got, what's the other one? Universal robots are they are these sort of cobots where they want to get them into the mass market, but they're more expensive. So a cobot of 5 kilogram tool load costs about $22,000. A big robot, the big one we have, is $120,000. So these cobots, which I just showed the animation, yeah, they're probably the cheapest on the market, for 5,000. Where you need to Google that. I mean, where do you get robots? You can get them where the factories are. I know UFactory has representatives in London, as far as I know, and ABB have representatives everywhere. They're the biggest robotic company on the planet, together, I think, with KUKA. Yeah. But it kind of depends what you want to do with them, what sort of application. I know, for example, Stäubli, they are an Italian make. They're very good for wood milling because they come from that region. So, yeah, I don't know. It kind of depends what you want to use them for.
Thanks.
And what tools. Obviously, a robot is just a means to an end. You need to also decide what do you actually want, what tool you want to put at the end, So what end effector you need. So, yeah, obviously, and then you need to build the tool for it. And you can build, the great thing about HAL, you can build everything in Grasshopper for it. Yeah. So if you have a tool, for example, we have a spindle, a milling spindle. So we can build everything for the milling spindle. We use these tools that are embedded in the HAL in the HAL framework. So that's very useful. There are free tools. It's more cumbersome. The Berkeley School of Architecture has a plugin that's called Robots. A lot of institutions and individuals use that. That's okay. That works, but you have to do a lot of the work that HAL, for example, does the heavy lifting in many areas. And I think checking whether the robot doesn't do any dangerous movements is also really HAL gives you the warning signals, and particularly when you scale up robots and you're not in the cobot realm that react every time you touch it, they will stop. But for example, the big IRB, they are potentially very dangerous tools. So you need to also have the relevant software that can deal with the bigger machines. Yeah. And I know, for example, I have great colleagues in Hong Kong U. They have a fantastic robotics, a whole huge laboratory with really big robots. They also use Grasshopper in the HAL framework, and they're specialists now. They go heavy into concrete printing. They just bought 2 new robots with a payload of 200 kilograms. So you can hang tools of 200 kilograms at the end. We have about 25 kilo. They are considerably small. But, we are an art school, so a big part is also you can make your own tools. So that will be also a big part of what we do. And for that, we will probably design the tools in Grasshopper and in Rhino and make them with whatever tools we have. Any other questions?
Yes, I have a couple of one. One that is related from Matthias Ferrero is we have a KUKA robot in our studio, but since the owner used it for milling, he's not he's not allowing us to use the KUKA PCR for Grasshopper nor experiment with it because of poor collision control and singularities issues. So we use Power Mill or Sprutcom, but they are extremely complex and no Grasshopper. Will you recommend to test and learn HAL and integrate it into our work system? Do you have some experience with both? Is it secure for the robot? Simulation, accuracy, singularities, collision, etc.
I have a great friend who is also helping us setting up our robot. He's has huge experience. Roberto Davolio, he's in Hong Kong. He has great experience with milling, and they use Sprutcam, and it's all about path development in Rhino. So I think he uses Sprutcam, and Grasshopper itself has so far not a parametric tool to develop tool paths for 3-dimensional objects like an STL or so. So you still have these classic milling programs like Sprutcam or Rhino Cam. There are a whole range of them, but they're also very expensive. Yeah, and usually you set up your milling tool, like with the Kuka, with Sprue Cam, and then it's like one system. Yeah, but we have a milling head, and I'm at the moment looking at this. So we will have to probably bite the bullet and initially buy a license for Sprue Cam, but we will integrate the toolpath. We will just develop the toolpath in as a curve in Rhino, and then import it as a curve into the Hull Grasshopper environment, and then do the TCP orientation in Grasshopper, because we have far more control over it. Also, yeah, things like collision, that is far, far better to simulate in the Hull environment, but you would need to be able to import a curve as a milling curve into the Grasshopper environment and work it from there on in Grasshopper. Do all your checks and balances, perhaps with Hull, and then once you're happy with that, you send the code back to the milling machine. So that's the way I want to set up our machine. So everything goes via Grasshopper. There is one company I am talking to at the moment, and I am hoping to get the money for. It's a company based in London in Germany. They are, what are they called again? They have already produced a great plugin which is called Woodbee. They are Parametric Zoo. Parametric Zoo. I was talking to them a few weeks ago, and they have produced a very simple milling path generator that is very cheap and is fully parametric and sits within the Grasshopper environment. And we're in discussions about developing a toolpath developer, basically a curve path developing tool for meshes, yeah, or B-reps, which we could integrate into the Grasshopper system. It's only a matter of time and money, but I hope we're gonna get there, because ideally, I think these classic and very pricey programs such as Sprue Cam and so on, I think they are inevitably will be phased out eventually once we have parametric tools that we can integrate into Grasshopper. And obviously, I know like Rhino, I mean, these milling tools are very expensive. The licenses cost from $10,000 upwards, and I think for smaller studios, it's really not something you want to shell out, you know. So, does that answer the question in a sort of a roundabout way?
I hope it does. Matthias.
Yeah.
That answer Matthias' questions. I have another one from Hannah D, which is, does craft inspire your technology process, or is it the other way around? And I'm gonna join with Pascal a question, which is, can you tell me more about your experience in Italy, if I heard correctly?
Okay, the first question, please, again. So, does the technology,
the craft inspire your technology, or is it the other way around? Does the technology inspire?
I think it's a dialogue. It kind of goes both ways. I see something, for example, that I develop in Grasshopper, and I think I would like to try this out in this material. But also I have material and I look for Grasshopper definitions. For example, I in the opening slide, let's go back. Oh yeah, this is my colleague Peter Nelson with the little cobots, where we also do Grasshopper code and paintbrushing. Let's go back to this one. Perhaps we go all the way back to the original slide. Here, this, for example, is eggshell inlay. So took me weeks to make this, but basically everything that is white is eggshell. The eggshells are cooked, and the inner peel, you know, when you open an egg, it has this little skin inside. So there are factories who just boil the eggshell and remove the skin. So because we only want to have the eggshell, and then basically you need to carve the out. You need to carve the area out in the lacquer, in the black lacquer that is here. You carve this area out with a knife to reveal the clay underneath. And then you lacquer this area and you embed the eggshell into it. And so this is a very lengthy process. And then you polish the eggshells down. And so once I saw that, I thought this is an interesting technique, but I want to develop something that is not what they use in Vietnam for. So I kind of designed, I thought I need to try to find a code that works with this technique. So it kind of goes both ways. Yeah. So so I start sometimes from both ways. Yeah. So they talk to each other. And the second question was experience in Carrara. Well, if you go to Carrara in Italy, I mean, I've worked also in Portugal for many, many years on and off. And in Italy, if you go to Italy, to the Carrara Mountains, there are all these little factories and they all have milling robots. You know, they mill on a grand scale. So I'm pretty sure I have heard just a few years ago, probably there must be more now. There must be between 300 and 500 big milling robots in Carrara Pietrasanta alone. And they're just milling everything. And a worker once there said it's basically like printing a photograph on a printer. You know, it's basically put a marble block into a milling robot and they mill it out. And it's, you know, they are very sophisticated and they can mill to very, very high precision. And the workers, they have to kind of retrain them because they're sort of finishers. They're not carvers anymore, they're finishing. So the hand is still important because the milling robot can go, I mean, you can run so many paths along the milling paths that you get really down to a fraction of a millimeter, but it still needs to be hand finished to get that sort of human touch, if you know what I mean. You know, so if, for example, I think in Bologna they have universities where they also train people up to work on milling robots. So it's a sort of, you know, a well-established, it's a very well-established technology now. They started sort of milling, interestingly, because I did interview a few people because I was interested in that and I did a research paper about it. Zaha Hadid did a table, a famous table that was milled. And I was talking to the guy who had a robot and he milled the first piece. And they managed to sell it via Sotheby's in an edition of 5. And it's that factor of making additions that made milling so attractive, because you can take a block, get a code, get a mesh, get the milling path, mill it, get it finished, but then you can make another one. You can make an addition like with bronzes, and that was in the past never really possible. It was very labor intensive, very time consuming and very costly. You had all these, there's a traditional method of making this as well, but now with robots, obviously it is far more efficient, much cheaper, and you can do it at much larger and quicker scale. So that's why you, I have noticed that when I was in London still, you know, I was living in London from 98 until 2017. And in and around 2010, 2011, I noticed all of a sudden all these marble pieces appeared in contemporary art shows. And I knew the people who were showing these marbles, I knew 100% that they couldn't carve shit, you know, because I'm a trained carver, I know how to carve, yeah. But I knew the artists who would work in that they would use factories. But I saw it, there was like in 2012, so there was so much marble all of a sudden on the Frieze Art Fair that I thought, what's happening here, you know? And then a year later, I was using a milling robot, and then I sort of realized, okay, yeah, everybody is milling now, you know, so it's just a factor in contemporary art. They are milling now, you know, because yeah, they can use these machines now. So that's about milling, but that's also only one aspect. I mean, I'm for example with the robots, I'm interested also working with perhaps musicians. Our art school, we have the visual arts, we also have the music department and the film department. So you know, we will have people who want to stick a camera at the end of a robot and do quick movements, and I don't know, film something falling down, for example, something you can't do by hand only, or you can set up a proper situation where you can do that with a robot, and you need to learn how to run the code for that, and try and error. And perhaps you start with small robots first, check whether the code works there, and then you can go to the bigger one. So yeah, stuff like that. It's important to just muck about with it, So that's why I think it's important to have them in art school. Anyway, that's wandering off. Anything else?
I think that's it. Well, you definitely got an amazing feedback that I will send you by email later, the chat.
Yeah.
But I think sorry, Braulio just wrote just greeting from Mexico and another nice feedback. So I think we can just wrap it up.
Yeah, we wrap it up. Well, to all of you, there's still 75 left, so a lot of people have gone to sleep now, and I go to sleep. It's 20 past 11. Well, thanks for having me.
Thank you so much.
And it's quite difficult to speak into a screen for such a long time, but I think COVID has honed me with my never really replying, very obedient Hong Kong students. So I'm kind of used to talking only in one direction, so it's not something I feel completely unfamiliar with. I'm also grateful that the technique has not packed up. I hope it was reasonably informative for anybody who wants to start in Grasshopper. There's a great online community out there, great help. Don't feel shy to ask people. Also in Food for Rhino, there's so much information there. Also, sometimes just take a look at a simple code, stick a panel at the end and see what you get out of a battery, and then, okay, and then go from there. But also do something you want to make, you want to produce something, so start with that intention, and that will be the impetus and the driving force behind it. I always give my students a little carrot. You want to produce something cool, so it's worth the effort at the end. So and that's the same for me. Now I'm next Monday I'm back in Hanoi in the lacquer studio, working, executing stuff that I developed in Grasshopper, and I could not do that without sitting all those hours learning it, And now I'm only doing it for 2.5 years, and I'm really looking forward to the next 10, 12 years where this is going, because I think it has fantastic potential. And it's also great because it's a great communicative tool, because you can send lumps of code to somewhere else, have a look at this, so particularly when you work with robots, I think that's also exciting, because you can take chunks of a Grasshopper code and stick it in WhatsApp and see what they do with another machine on the other side of the world, with this code, so that's what we're already doing. So yeah, onwards and upwards.
Definitely very inspiring, even more to see the different and the versatile applications with Grasshopper, more in robotics and more destinated to something as beautiful as art. So thank you so much for that. I think we can talk from everyone here that it was extremely inspiring, very motivational, and everyone wants to just leave and start playing with Grasshopper to see and create something.
Well, obviously, thank you so much for inviting me. Thanks everybody for sticking with me for 1.5 hours. Have a glass of wine and go to bed now. Thank you so much.
Here in Barcelona, it's still early.
Exactly.
But I'll hope to see you soon and to see more of your work or another exhibition.
I will keep my website updated, but also I'm pretty sure there will be soon more coming from our lab here in Hong Kong. So watch this space.
Okay, and thank you everyone for joining us and for being here with us. I hope to see you in the next webinar, and have a lovely afternoon or night, depending where you are. Thank you. Bye.
Good night. Good night from Hong Kong.
Good night.